Here are us to find the descriptions of the polynomial we're trying to find the degree, the zeros, the end behavior, and the equation, which doesn't say here that a is equal to 1, so I got to figure out what that a value is too. So the first thing is I'm going to go ahead and find the zeros just because that's the easiest, I think, because I'm just looking for where does it touch the x-axis. So I see that it touches at -3, -1, and +2, and +5. So 4 of them there. Next, when I look at the end behavior, a couple things about end behavior. When I look to the left here, I say as x goes towards -infinity, I see that my graph is pointing down, so I go towards -infinity. As x goes towards +infinity, meaning as we go to the right, y is also pointing down, so we go towards -infinity again. Now for the degree, a couple things that we can do here. I'm going to go ahead and I could either know the general shape, or I can actually count how many turns there are. So if I'm starting by going uphill here, that's going to be a degree of 1. But then I turn to go down, so that's 2. Then back up is 3, and down is 4. So this is going to be a 4th degree polynomial. Next, what I need to do is find the equation. So to find the equation, first of all, I'm going to use my zeros here. A couple things about the zeros. I know that there are 4 of them, so I'm going to say, there's 4 sets of parentheses here that I'm going to fill in with some stuff. First one here, I'm going to say is x plus 3, because I know if I plug in -3, that's going to give me 0. X plus 1, because if I plug in -1, it gives me 0. X minus 2, because if I plug in 2, that gives me 0, and x minus 5. Now, when I look back at this equation here, on the graph, none of the zeros are being bounced off of, meaning that none of these are going to be squared. But in this one here, I'm actually not given that a is 1, so I actually need to figure out what a is equal to. So right now I'm just going to put a as a variable in there. Now it's weird because I have 3 variables here. I have my y, I have a, and I have x. But what's going to help me find this is the y-intercept here, because that point right there is at 0, -3, which gives me an x and a y value so that we can solve for a. So what that means is I'm literally plugging that in. -3 equals a times 0 plus 3, 0 plus 1, 0 minus 2, 0 minus 5. I'm just plugging in that x and y value of the y-intercept. Now I'm going to simplify here a little bit. A times 3, 1, -2, -5. 3 times 1 is 3, times -2 is -6, times -5 is +30. So -3 equals 30 times a. Divide both sides by 30. I get a equals -3 over 30, which is -1/10. So now I know my a value. So my final equation here, nice and pretty, f equals -1/10 times x plus 3. And now I'm just taking this from my purple equation there, x plus 1, x minus 2, x minus 5. And that gives me my final equation with an a value that's not 1. We see that it's a negative a value, which makes sense because our even degree function is facing downwards.